This is a demonstration of Marina Photonics P-Count G, which is a gated photon counter capable of counting 1 gigahertz rate photons. The input photon comes into here. It can be a pulse as narrow as 100 picoseconds and a repetition rate as great as 1 gigahertz. The device may be triggered to start collecting photons either with an external trigger, or it may be triggered with a push button, or you can latch it down to be triggered. Lifting the switch resets everything. There's an external gate here, and the external gate width is what determines the time that the photon counter captures photons. This gate gates the 1 gigahertz clock off and on, so that the width of the external gate determines how many nanoseconds you count photons. I have tested this device down to 2 nanoseconds gate width, which means it would run certainly 200 megahertz gate width and gate rate, and it can be adjusted for threshold so that the input gate can be anywhere from 1.1 volts to 3.3 volts maximum. So let's turn on the photon counter, and what you see on the oscilloscope on trace 1, the white one, is the output of the gate from the 100 kilohertz gate generator. It turns out that the 100 kilohertz gate generator has a fixed width, so we'll be always dealing with 500 nanosecond widths. Now that's 100 kilohertz gate rate. I'm going to go down to 1 kilohertz gate rate, and nothing has changed on the oscilloscope because we're triggering on the external gate. The green trace is a simulated photon count from a pulse generator. And I'm going to use that to show how one can count photons or count photons in a burst mode. The bottom trace is the gigahertz clock output from the photon counter. It's not triggered now, so what I'm going to do is manually trigger it, and you see the 1 gigahertz clock appears. All the green photons will now be captured by the 1 gigahertz clock and sent to the computer. Just so we understand this, I'm going to switch to a computer output from the USB of the photon counter, and we can look at the photon counts coming out and being displayed on 2 screens. The screen on the left has 10,000 points. The screen on the right has 200 points. So I have captured so many photons on the 10,000 screen that they all look run together. On the right, you have 200 nanoseconds of photon counting, and a bit of explanation is in the order. Each one of these positive pulses, which goes up, is flat, goes down, is flat, goes up, is flat, etc., consists of 2 photons, because I have divided the photon count by 2, and it makes it easier to see them and to understand the relationship of one photon to another. The width of the top is the distance between 2 photons, and the width at the bottom is the distance between 2 photons. And if you look at the oscilloscope screen, and I'll adjust that down so you can see both now. If you look at the oscilloscope screen, you can see that the clock is running continuously. Well, now why would you not want to do this? Well, at 1 kilohertz, you get a lot of photons, but you don't particularly want to have all that dead space. So let's go to gated. And go back up to 100 kilohertz. And you'll begin to see the advantage of gating. Well, you still seem to have a lot of photons. Well, that's fine. So why in the world would anyone want to gate? You can see the upper trace at 255 are the fiducials that mark the gate width. So I am gating the photon counter. So what's the difference between gated and not gating? Well, suppose you don't have a continuous rate of photons. Suppose you just have a burst of photons. Aha. Now, if you look at the oscilloscope, you see 4 photons within the gated mode. And if you go to the ungated photon counter mode, what you see is bursts of 4 photons. Just to illustrate what this is really doing, let's go down to 50 kilohertz external burst mode rate. So the external burst mode rate is now 50 kilohertz, and you can see that the burst of photons is separated by quite a bit, and there's a lot of dead space. So what does the gating do for you? The gating fills up that sparse space with nothing but data, or at least as much data as there is within the gate. And now if you look at the right side of the screen, you see that between the fiducials it goes down, up, down, up. That's 4 photons. Let's extend the width of the burst a bit. Now I have 6 photons coming out, and as expected, you see 3 pulses on the bottom, down, up, up, down, up, down, up, down, corresponding to 6 photons. This is the gated mode. The trace on the left on the computer screen shows that almost all the data that's being stored in the computer is photon counts. And if I turn off the gated mode, then you see there's a lot of dead space between it. This is not what you want. Let's go down to 20 kilohertz to illustrate this just a little bit better. Okay, now you have 20 kilohertz burst rate. The gate is still the same width. There's a lot of dead space between the photon counts, so you're storing a lot of nothing. But in the gated mode, you go back to a full screen of photons on the left on the computer, and you see that once again you have 6 photons on the right between each gate. That's at 20 kilohertz. So I'm going to go up to 125.5 kilohertz burst rate, which is the maximum I can do, and the waveform does not change at all. The photon counter is seeing all of the 6 photons within the gate that's coming to the photon counter. It's not missing any, and the rate at which the burst comes in does not matter. So once again, we'll look at the photon counter. We're going to reset it. And on the back of the photon counter, you also have a positive gate out, a negative gate out, the 1 gigahertz clock, a triggered out, that is, it will be positive when the system has been triggered. The light goes on, the level goes up on the back, and it will also have a 125 megahertz clock, which is a gigahertz divided by 8, that may be useful for some other purposes. If you'd like to have one of Marina Photonics' excellent gated photon counters, they come in 1 channel, 2 channels, or 3 channels, plus an additional channel for the gating function. If you'd like to have one of these, call me at 831-384-6780, and that is Marina Photonics Incorporated. Thank you.